You know what the movies got wrong? Pretty much everything about how German tanks actually met their end during the Second World War. All those dramatic scenes with Tigers and Shermans squaring off in some dusty French village, commanders shouting orders through their headsets, gunners frantically traversing turrets, the metallic clang of armor-piercing rounds bouncing off thick steel plates. It makes for incredible cinema, sure, but it's a fantasy. The actual numbers tell a completely different story, one that's far less glamorous and infinitely more grinding. When historians sat down and crunched the data from Wehrmacht loss reports, maintenance logs, and post-war analyses, they discovered something that would shock anyone raised on a steady diet of tank battle footage. Those epic armoured duels that dominate every documentary and feature film about the war. They accounted for less than a third of all German tank losses, not even close to half, less than 30%. Let that sink in for a moment. So if the majority of Panzers weren't being knocked out in heroic shootouts, where were they going? How does a military force lose hundreds and hundreds of sophisticated fighting machines without the enemy even pulling a trigger? The answer is simultaneously mundane and devastating. Most German tanks simply stopped working. They broke down on country roads. They ran out of fuel in the middle of nowhere. They got stuck in mud so deep that no amount of engine power could drag them free. Their crews, facing the choice between abandoning a valuable piece of equipment or getting captured themselves, often chose to blow up their own vehicles and march away on foot. This wasn't some occasional occurrence, some unfortunate exception to the rule of armoured warfare. This was the rule. The exceptions were the tanks that actually made it to the front line, fought for a while, and eventually got destroyed by enemy fire. Think about what that means for a second. You're a German tank commander somewhere in Russia during the summer offensive of 1944. You've trained for months, maybe years. You know your vehicle inside and out, every gauge, every lever, every quirk of the engine. Your crew has practiced loading drills until they can do it with their eyes closed. You've studied tactics, learned how to use terrain, memorized the silhouettes of enemy vehicles. And then what happens? You get maybe 50 kilometers from your assembly area before the transmission starts making a horrible grinding noise. The mechanic takes a look, shakes his head, says you need a part that won't arrive for 3 weeks, assuming it arrives at all. So there you sit, this enormously expensive, beautifully engineered weapon of war, completely useless because of a piece of metal the size of your fist that nobody can find. Meanwhile, the enemy is advancing, your infantry needs support, command is screaming for your unit to move up, and you're watching your war end not with a bang, but with a mechanical whimper. Now, here's where it gets really interesting, really damning for the whole German war machine. This wasn't a secret. It wasn't some unexpected problem that caught everyone by surprise. The Germans knew their tanks were maintenance nightmares. They'd known it for years. Their own manuals, their own testing reports, their own mechanics had been warning about this since before the war even started. The Tiger tank, that legendary beast that's become synonymous with German armour, had a final drive mechanism that was essentially designed to destroy itself. Engineers had calculated that under normal operating conditions, you'd need to replace this critical component after the vehicle had travelled just 500 metres. Not 500 kilometres. 500 metres. That's like 5 city blocks. Imagine building a car that needed a new transmission after driving to the grocery store. Now imagine trying to wage a continental war with thousands of these things, each one requiring constant replacement parts that have to be manufactured in factories that are getting bombed around the clock. And speaking of those factories, let's talk about what was happening back in the Reich while these tanks were supposedly conquering Europe. By 1944, the Allies had figured out something crucial. You don't need to destroy every German tank on the battlefield if you can stop them from being built in the first place, or better yet, if you can build them but make sure they can't actually function. British and American bomber crews started hitting specific targets, not just carpet-bombing cities, but going after the industrial choke points. Ball-bearing plants became priority targets. Now, you might wonder why ball bearings matter so much. Here's why. Every tank needs hundreds of them. The Panther tank, which looked absolutely deadly on paper and could knock out pretty much any Allied tank from ranges that made the enemy look like toys, required roughly 200 separate ball bearings just to function. These weren't interchangeable with ball bearings from other machinery. They had to be precision manufactured to exact specifications. They had to be the right size, the right metallurgy, the right tolerance. The Allies knew this. Intelligence reports had identified the factories in places like Schweinfurt where these components were being made, so they sent waves of bombers, hundreds of them, knowing that every ball-bearing plant they knocked out would have ripple effects across the entire Panzer force. And it worked. It worked devastatingly well. By late 1944, German maintenance units were reporting Panthers sitting in depot yards, perfectly functional in every way, except they couldn't move because they were missing bearings. Factory-fresh vehicles would arrive at the front and immediately break down because the bearings they'd been fitted with were substandard, made by slave labourers sabotaging production or by overworked German workers using whatever materials they could scrounge. One German mechanic, in a letter that somehow made it home past the censors, wrote something that should be carved into every history book about this period. He said they had these beautiful machines, masterpieces of engineering that could theoretically destroy anything the enemy fielded, sitting completely useless for want of a tiny gasket that probably cost less than a single meal. A gasket, not a gun barrel, not armour plating, not some exotic piece of technology. A rubber gasket worth pennies. The Panzers weren't just fighting the Shermans and the T-34s and the Churchills. They were fighting a war of attrition that started the moment raw materials left the mine, that continued through every step of the manufacturing process, that intensified when components had to be transported through rail networks that were being bombed daily, and that reached its peak when these vehicles finally arrived at the front lines already worn out from the journey. Think about the geometry of the problem. Germany was fighting on multiple fronts across thousands of kilometres, in terrain ranging from desert to Arctic tundra. Every panzer division needed spare parts. Every workshop needed tools and trained personnel. Every supply line needed to stretch back to factories in the Ruhr Valley or wherever else they were building this stuff. Now imagine trying to maintain that network when enemy aircraft can hit your trains, your depots, your roads, your bridges, your ports. The logistics alone should have made victory impossible, and ultimately, that's exactly what happened. The Germans lost the logistics war, and once you lose that, you lose everything else, no matter how good your individual weapons might be. But let's move on to the second major killer of German armour, because this one is even more grimly fascinating. Mines. Simple, cheap, mass-produced explosive devices that you bury in the ground and forget about until someone drives over them. The Russians, who had watched the Germans tear through their territory in the early years of the war, developed a deep appreciation for the mine as a weapon. They didn't need sophisticated guidance systems or expensive materials. They needed something that could be stamped out by the millions in factories that were crude even by wartime standards, something that a peasant conscript could learn to plant in 5 minutes, something that would stop a German tank column dead in its tracks without requiring a single Soviet tank to expose itself to enemy fire. So they built mines. Lots and lots of mines. Estimates suggest the Red Army deployed somewhere in the neighbourhood of 200 million of them over the course of the war. 200 million. That number is almost incomprehensible. Imagine trying to advance across territory where every single square metre might contain a device waiting to explode under your treads. The economics of this are staggering when you break them down. A Soviet TM-41 mine, one of the most common models, cost maybe $3 in contemporary currency to manufacture. It was a simple pressure-activated device, nothing fancy, just explosives in a metal case with a trigger mechanism that couldn't be much simpler if you tried. $3. Meanwhile, a King Tiger tank, the heaviest and most fearsome vehicle Germany produced, carried a price tag of 300,000 Reichsmarks. Converting that to dollars is tricky because exchange rates were weird during wartime, but we're talking about something like $100,000 or more in equivalent value. So you've got this 100-to-1 cost ratio. maybe even a 1,000-to-1 ratio. And the crazy thing is, the $3 mine wins almost every time. It doesn't have to completely destroy the tank. It doesn't have to kill the crew. All it has to do is break the track. Just snap that continuous loop of metal links, and suddenly your 60-ton fighting vehicle becomes a 60-ton stationary target. Here's where the terrain makes everything worse. The Eastern Front, especially during certain seasons, turned into a nightmare of mud. Not just regular mud, but this thick clinging stuff that could swallow vehicles whole. The Germans even had a name for it, Rasputitsa, borrowing the Russian term because their own language didn't have adequate words to describe the horror of spring and fall when the roads essentially ceased to exist. During these periods, tracked vehicles could barely move under ideal conditions. Now add a mine strike. Your track breaks, and you're not on a nice paved highway where a repair crew can show up with replacement links and have you moving again in an hour. You're in the middle of nowhere, possibly under fire, definitely under time pressure because the front is moving, and if you don't get this vehicle mobile soon, it's going to be overrun or abandoned. The crew works frantically, but the ground is so soft they keep sinking. The tools are getting caked with mud. Every step is exhausting. Meanwhile, Soviet infantry might be closing in, or worse, Soviet artillery has your position registered and shells are starting to fall. In those conditions, a lot of crews made the rational decision to just blow the demolition charges, strip anything valuable from the vehicle, and get out on foot before they became casualties themselves. American intelligence officers who studied the Normandy campaign came to similar conclusions, which was surprising because a lot of people assumed the Bocage country of France would favour different tactics and different weapons. But no, even there, mines and improvised explosive devices destroyed more German armour than dedicated anti-tank weapons. Tank destroyers, bazookas, sticky bombs, all the specialised equipment Allied troops carried for dealing with Panzers, that stuff all combined accounted for fewer kills than buried explosives. The Germans themselves acknowledged this in their after-action reports. One commander filed a bitter assessment where he noted that his men were constantly scanning the horizon for enemy vehicles, searching the tree lines for anti-tank positions, watching the ridge lines for hull-down tanks, while the real danger was literally beneath their feet with every metre they advanced. You can't fight mines the way you fight tanks. There's no duel, no contest of skill or courage. You either find them before you hit them, which is slow and dangerous work, or you hit them and deal with the consequences. The psychological toll was immense. Tankers started to dread every advance, knowing that any moment could bring that sudden crack of an explosion beneath the hull, the sickening lurch as the track separates, the awful second of confusion before you realise whether you've just been disabled or actually penetrated. So we've covered logistics failures and we've covered mines. What about actual combat deaths, the times when German tanks were destroyed by enemy weapons in direct engagement? Here's where things get really interesting, because the answer still isn't tank-on-tank combat. The actual biggest killer in direct engagement was artillery. Big guns firing from kilometres away, lobbing shells in high arcs that came screaming down from above. The Soviets turned this into an art form, developing tactics they called the artillery fist, or sometimes the artillery steamroller, depending on who's translating. The concept was brutally simple. Whenever German armour appeared, you didn't send your own tanks to meet them. You called in the map coordinates to your artillery batteries, and you smashed that entire grid square with everything you had. The Red Army had guns by the hundreds, sometimes by the thousands, all pre-registered on likely avenues of approach, all ready to fire within minutes of getting the word. The mathematics of artillery versus armour are horrifying for the tank. Most people think you need a direct hit to kill a tank with an artillery shell, and that's true if you're using smaller caliber weapons. But the Soviets loved their heavy guns, especially the 152mm howitzers that could throw a shell weighing nearly 100 pounds. When one of those lands within 10 metres of a tank, not on the tank but near it, the overpressure alone can be catastrophic. The blast wave hits the vehicle from every direction simultaneously. Armor plating is designed to deflect projectiles coming from specific angles, not to withstand pressure waves that envelop the entire vehicle. Hatches blow open, tracks snap from the concussive force. Crewmen inside suffer terrible internal injuries, even if the tank's structure remains intact. And that's before we talk about near misses that flip tanks completely over. A Panzer isn't a sports car. The centre of gravity is high, and while they're stable under normal driving conditions, if a massive explosion goes off right next to them, physics takes over. Witnesses reported seeing 30-ton vehicles literally lifted off the ground and dropped upside down or on their sides, at which point the crew either dies in the impact or bails out if they can. The Battle of Kursk provides the most stark example of artillery dominance. This was supposed to be Germany's big comeback, their chance to regain the initiative on the Eastern Front after the disaster at Stalingrad. They massed hundreds of tanks, including the newest Panthers and Tigers, and they prepared meticulously for what they thought would be a decisive breakthrough. The Soviets knew they were coming, had known for weeks thanks to good intelligence, and they prepared defences in depth. Not just trenches and infantry positions, but artillery concentrations that would make the ground itself explode. When the Germans attacked, they ran into a killing zone unlike anything they'd experienced. Soviet batteries opened up, and for 3 solid hours, certain sectors received continuous bombardment. Shells fell like rain, throwing up enormous fountains of dirt and steel, creating craters deep enough to hide a jeep. When the barrage lifted, Soviet observers counted German tanks that had been destroyed, and the numbers were staggering. More Panzers had been wrecked by those 3 hours of artillery than had been knocked out by tank-on-tank combat in the previous 3 days of fighting. The Germans tried to adapt, tried to spread out, tried to move faster to get through the kill zones, but you can't outrun artillery fire when the enemy has your position plotted and guns that can drop shells on you from ranges beyond your vision. The Western Allies brought their own twist to the artillery nightmare. American guns were devastating enough on their own, but what really changed the game was a technological innovation that sounds almost too perfect to be real. The proximity fuse, sometimes called the VT fuse, which stands for variable time, even though it's actually a tiny radar unit. Here's how it works. You fire an artillery shell, and instead of exploding on impact with the ground or after a set time delay, it carries a miniature radar set in the nose. As the shell descends toward the target, the radar starts pinging, and when it detects it's getting close to something solid, it detonates the shell in mid-air. The result is an airburst explosion that showers the area below with shrapnel. Now, if you're infantry in a foxhole, this is bad but survivable if you're dug in deep enough. If you're in a tank, this is an absolute catastrophe, because tanks have thin armour on top. They're designed to fight other tanks, which means thick frontal armour to stop incoming rounds and decent side armour in case someone gets a flanking shot. But the top, the roof of the turret and the engine deck, often just 25 millimeters of steel, sometimes even less. That's enough to keep out small arms fire and shell fragments from ground bursts, but against a proximity-fused shell that's specifically designed to explode above the target and rain metal straight down, it's like tissue paper. American artillery units got terrifyingly good with these fuses. They'd get a radio call from a forward observer who'd spotted German armour, and minutes later shells would be arriving overhead, not landing near the tanks but detonating 50 metres up and sending thousands of white-hot fragments straight down through the vulnerable top armour. Tank commanders who rode with their heads out of the hatch for visibility, which was standard practice because trying to fight buttoned up was like trying to fight blind, they were killed instantly. Just decapitated by shrapnel before they even knew rounds were incoming. Crews would button up once they realised they were under artillery fire, but then they were stuck inside a metal box with extremely limited vision, basically deaf because of the explosions, unable to manoeuvre effectively, and all the while shells kept falling. The psychological impact was worse than the physical damage. One Panzer veteran who survived the war wrote in his memoirs that American artillery was more terrifying than anything else they faced, including Soviet tanks, including Allied fighter bombers, including everything. His reasoning was simple and awful. You can't fight artillery. You can't shoot back at something you can't see, can't duel with guns that are firing from positions kilometers away, can't outrun shells that are already in the air before you even know they've been fired. All you can do is sit there and take it and hope the next one doesn't land on your position. Now, artillery and mines and logistics failures were the big killers, but there were also these fascinating niche weapons that proved surprisingly effective against German armour. The Soviets, who were masters at doing more with less, developed something that on paper shouldn't have worked at all. It was an anti-tank rifle, the PTRD-41, which is basically exactly what it sounds like. A rifle designed to shoot tanks. Now, when people hear that, they usually laugh because the idea seems absurd. Rifles fire bullets. Tanks are armoured vehicles specifically designed to be immune to bullets. How is this supposed to work? Well, it doesn't work the way you'd think. The PTRD-41 fired a 14.5mm round, which is huge for a rifle but tiny compared to tank guns. That round could not penetrate the frontal armour of a Tiger or a Panther or even most medium tanks. The Soviets knew this. They weren't idiots. They weren't issuing these weapons thinking their infantry was going to be punching through armour plate. What they figured out was something far more clever and far more insidious. Tanks have weak points. Not weak in the sense that the armour is thin, though sometimes that's true, but weak in the sense that they're critical systems that are exposed or vulnerable. Vision devices, for instance. A tank commander needs to see where he's going, which means periscopes and vision slits and observation ports. These are made of glass or crystal or similar materials, and while they're designed to be tough and bulletproof to a degree, they're not designed to withstand sustained fire from a 14.5mm rifle at close range. Soviet infantry tactics developed around this vulnerability. You'd get a squad with a couple of PTRD-41 rifles, and they'd set up in a position where they could get shots at German tanks from the side or from elevated positions. Then they'd just pour fire into the vision devices. 20 rounds, 30 rounds, however many it took. The glass would crack, then shatter. Periscopes would get knocked out. Vision slits would get blocked with fragments of metal and crystal. What happens to a tank when its crew can't see? It becomes useless. The commander buttons up completely, which means he's now trying to navigate and fight from inside a sealed metal box with maybe a few tiny vision blocks that are themselves compromised. The driver can't see obstacles, can't avoid ditches, can't tell if he's about to drive into a building or off a cliff. The gunner can't acquire targets. Essentially, you've turned a sophisticated weapons platform into a blind, stumbling hazard to itself. Soviet accounts describe watching German tanks that had been blinded by rifle fire wandering around the battlefield like wounded animals, scraping against buildings, falling into craters, or just stopping completely while the crew tried to figure out what to do. And if the crew tried to open a hatch to look out and assess the situation, well, that's when small arms fire from Soviet infantry would pour in, forcing them to seal up again or abandon the vehicle entirely. The economics of this approach were stunning. The Soviet Union manufactured roughly 471,000 PTRD-41 rifles over the course of the war. Each one cost about 193 rubles to produce, which in contemporary terms was maybe $50 or so. Compare that to the 300,000 Reichsmarks for a Tiger tank, and you're looking at asymmetric warfare in its purest form. A $50 rifle operated by a conscript with minimal training could mission kill a vehicle that cost thousands of times more and required a highly trained crew. This is the kind of math that wins wars. Not sexy math, not the kind of thing that makes it into movies, but brutal economic reality. You don't need to destroy enemy equipment if you can render it useless for a fraction of the cost. Then we need to talk about aircraft. Because while ground-based weapons were doing most of the killing, Allied air power added a whole other dimension of misery for German tank crews. The British developed a system they called cab rank, which was borrowed from the concept of taxis waiting in line for fares. Fighter bombers would circle over the battlefield in holding patterns, waiting for forward air controllers on the ground to radio in targets. When German armour appeared, the controller would call in a strike, and within minutes, aircraft would be diving on the position with rockets and bombs. The Hawker Typhoon became infamous for this role, carrying 8 rockets under its wings, each one capable of penetrating tank armour if it hit directly. Now, here's the thing about rocket accuracy from a diving fighter bomber. It's terrible. Studies done after the war showed that direct hit rates were below 5%. Out of every 100 rockets fired, fewer than 5 actually struck the target they were aimed at. That sounds like a failure, like a waste of resources, until you realize that direct hits weren't really the point. The psychological impact of air attack was paralyzing for tank crews. Imagine you're buttoned up inside a Panther, vision already limited because you're closed up tight to protect against artillery. Suddenly you hear the scream of aircraft engines, that distinctive rising whine of a plane in a dive, and then the whoosh of rockets launching. You have no idea where they're going to land. You can't see them coming. You can't shoot back effectively because your machine guns have limited elevation and you're not going to hit a fast-moving aircraft with your main gun. All you can do is sit there and pray. Even if the rockets miss, they're exploding close enough to shake the tank, to send fragments clanging against the armour, to remind everyone inside how vulnerable they are. The effect on German armoured tactics was profound. Units stopped moving during daylight hours when Allied air superiority was unchallenged. They'd hide under trees, park next to buildings, cover their vehicles with camouflage netting, anything to avoid being spotted from the air. This meant they could only manoeuvre at night, which cut their operational tempo in half or worse. And here's the real brilliance of the cab rank system. Even when the aircraft weren't hitting targets directly, they were forcing German armour to bunch up in covered positions. Tanks that should have been spread out across kilometres of front would instead cluster together under the same grove of trees or in the same village, trying to hide from aerial observation. What happens when you bunch up armour like that? You create a perfect target for artillery. A forward observer spots the concentration, calls in the coordinates, and suddenly those tanks that were trying to hide from planes are getting hammered by guns they can't even see. The aircraft and the artillery worked together in this beautiful, terrible synergy. The planes forced the tanks to stop moving and cluster together. The artillery destroyed them once they were stationary and grouped. Neither weapon needed to be perfectly accurate because they were working as parts of a system, and the system was devastatingly effective. Let's zoom out and look at the industrial dimension of this, because understanding what killed German tanks requires understanding how World War II was fundamentally an industrial conflict. Germany manufactured roughly 49,000 tanks and assault guns during the entire war. That's not an insignificant number. 49,000 armoured vehicles is a lot of steel, a lot of manufacturing capacity, a lot of resources. But their enemies, just the Soviet Union, the United States and Britain combined, produced somewhere around 227,000 tanks. Not counting all the other allies, not counting tank destroyers or self-propelled guns or any of the other armoured vehicles, just tanks. That's better than 4-1 numerical superiority before the first shot is ever fired. Now, Germany tried to argue that quality would overcome quantity, that their superior engineering and superior tactics would allow them to achieve exchange ratios that would negate the numerical imbalance. And to some extent, this was true in individual engagements. A Tiger or a Panther could absolutely dominate a Sherman or a T-34 in a one-on-one fight, assuming everything else was equal. But everything else was never equal, and that's the crucial point. Those exchange ratios the Germans needed, they were never going to get them because tanks weren't fighting in isolation. They were fighting in a complex system that included logistics, air power, artillery, mines, infantry and terrain. A German tank might be superior in gun range and armour protection, but those advantages meant nothing if it ran out of fuel, or if it got its track blown off by a mine, or if artillery started falling on its position, or if aircraft forced it to hide during the day. The math becomes pretty simple when you work it out. Even if every single German tank knocked out 10 Allied tanks before being destroyed, which absolutely did not happen, but let's pretend, they'd still run out of tanks before the Allies did. 10 times 49,000 is 490,000. The Allies built 227,000 and could have built more if they needed to. And again, that's assuming a 10-to-1 kill ratio, which is fantasy. Real kill ratios varied wildly by engagement, by terrain, by which units were involved, but they were nowhere close to what Germany would have needed to make the strategy work. What really gutted the German armoured forces wasn't the fighting at all, at least not directly. It was the slow grinding attrition that happened constantly, in every sector, every single day. Tanks broke down. They got stuck. They ran out of fuel. Replacement parts didn't arrive. Mechanics who could have fixed them were dead or reassigned. Recovery vehicles that could have towed disabled tanks back to depots were themselves broken or unavailable. Training for new crews got shortened because there wasn't time to do it properly, which meant those crews made mistakes that damaged vehicles or got them killed in situations where veterans would have survived. Everything was degrading all at once, like a machine running without lubrication, getting hotter and hotter until components start to fail. And you can't fix that kind of systemic collapse with better tactics or braver soldiers or more advanced technology. Once the logistics network starts to fall apart, everything else follows. The bombing campaign against German industry intensified as the war went on, and by 1944 and 1945 it had reached levels that are hard to comprehend if you haven't studied the numbers. We're talking about 1,000 bomber raids, waves of aircraft so large they'd show up on radar as solid masses. Cities would be hit repeatedly, sometimes within days of each other. Factories would get repaired just enough to resume partial production, and then they'd get hit again. The cumulative effect was that German industrial output started to collapse, even though they were supposedly throwing everything they had into war production. Tank production numbers look decent on paper for 1944, but what those numbers don't show is how many of those tanks were being built with substandard parts, how many left the factory with problems that should have been caught in quality control, how many arrived at the front already needing repairs. There are reports from German maintenance units that read like dark comedy if the situation weren't so grim. Brand new Panthers arriving from the factory with transmissions that were already failing. Tigers showing up without proper gun sights because the optics factory had been bombed and nobody had replacements. Crews being told their tank was ready, but they'd need to wait for ammunition because the shell production lines had been disrupted. It's like getting a car delivered where the engine runs, but there are no wheels, or the wheels are there but the steering doesn't work. At some point, you're not actually getting functional equipment, you're getting containers of metal that happen to be shaped like tanks. And this is happening while your enemies are producing vehicles that might be inferior in some technical specifications, but they work, they're reliable, they can be repaired with parts that actually exist and arrive when needed. And there are so many of them that losing a few doesn't matter. The Eastern Front became a particular nightmare for German logistics because of the distances involved and the condition of the infrastructure. Soviet rail networks used a different gauge than European railways, which meant German trains couldn't just roll deep into occupied territory. Everything had to be offloaded and transferred to captured Soviet rolling stock or trucks, adding time and complexity to every shipment. Roads were terrible, often just dirt tracks that turned into rivers of mud during bad weather. Supply convoys would get bogged down, sometimes for days, while the tanks they were supposed to be supporting ran dry on fuel or ammunition. And this is all happening while partisan groups are blowing up bridges, mining roads, ambushing supply columns, doing everything they can to make the German supply situation even worse. It's one thing to fight an enemy army. It's another thing entirely to fight an enemy army while the entire country you're occupying is actively hostile and working to cut your supply lines. German tank crews developed a gallows humour about the fuel situation. They'd joke that their tanks had a combat radius measured in metres rather than kilometres because they'd get to the front line and immediately have to start worrying about whether they'd have enough fuel to withdraw if things went bad. And this wasn't really a joke, it was just reality. There are documented cases of German units having to decide which tanks to fuel because there wasn't enough to go around. So you'd take the most combat-ready vehicles, the ones with the best guns and the most experienced crews, and you'd give them the precious fuel while other perfectly functional tanks sat immobile because feeding them wasn't possible. Then when those fueled tanks got knocked out or broke down, you'd try to redistribute whatever fuel they had left to the remaining vehicles, this constant shell game trying to keep something, anything, operational. The absolute darkest chapter in this whole grim story comes at the very end of the war. By 1945, the situation had deteriorated so completely that more German tanks were being destroyed by their own crews than by enemy action. Read that again because it sounds impossible, but it's documented fact. Wehrmacht records from April and May of 1945 are full of entries that say things like destroyed by crew, no fuel, abandoned and demolished, self-demolition due to lack of ammunition. Panzer units retreating through Germany itself would roll into a town, realise they didn't have fuel to go any further, and they'd wire demolition charges to their vehicles and blow them up rather than let them be captured intact. Crews would sometimes try to push tanks into rivers or off bridges, anything to deny them to the enemy, but often they didn't have the resources or the time even for that, so they'd just set explosives and walk away. Imagine being a tank crewman in that situation. You've survived years of war. You've fought across half of Europe. You've seen friends die. You've watched your country slowly lose. And now you're sitting in the middle of Germany, supposedly defending the homeland, and you're being ordered to destroy your own vehicle because there's no fuel to move it and no ammunition to fight with it. The enemy isn't even in sight. You're not going down fighting. You're just giving up and blowing up a perfectly functional piece of equipment because the systems that were supposed to support you have completely collapsed. That's not war in any traditional sense. That's organizational death, the final spasm of a military machine that's run out of everything except the will to make sure the other side doesn't get their hands on the scrap metal. This pattern of self-destruction accelerated as Germany's infrastructure imploded. Rail networks were so thoroughly bombed that moving anything by train was nearly impossible. Bridges were down, fuel depots had been captured or destroyed. Supply officers were dealing with situations where they knew where supplies were but had no way to move them to where they were needed. Units would be separated from their supply lines by enemy advances, and once isolated, they'd last as long as whatever fuel and ammunition they had on hand. Then it was over. Some crews tried to fight to the last shell, going down in a blaze of glory, but most realized that was pointless and just surrendered or fled on foot after rendering their vehicles unusable. The final accounting shows that tens of thousands of German armoured vehicles were lost not to enemy fire, but to this systematic collapse of sustainability. Throughout all of this, there's this consistent thread of German engineering creating problems that German logistics couldn't solve. The people designing these tanks were brilliant, absolutely world-class engineers who understood metallurgy and ballistics and automotive design. But they were designing in a vacuum, not accounting for the reality of how these vehicles would actually be used. They created the Tiger, which was a magnificent machine that could dominate any battlefield it appeared on, but which was so heavy and so complex that keeping it running required a supply chain Germany simply didn't have. They created the Panther, learning from the T-34's sloped armour and good gun, but they made it too sophisticated, too dependent on precision parts that couldn't be manufactured in sufficient quantities under wartime conditions. They kept iterating, kept improving, kept making these vehicles more and more capable on paper, while the practical reality was that simpler, more reliable designs would have served them better. The Allies, by contrast, built tanks that were often inferior in direct combat, but superior in every other way that mattered. The Sherman tank gets mocked constantly for being undergunned and under-armoured compared to German heavy tanks, and that's fair criticism if you're only looking at the technical specifications. But Shermans were reliable. They could be repaired by moderately trained mechanics using parts that were actually available. They could run on the fuel that was actually being produced and delivered. They could be manufactured in quantities that made losses irrelevant. When a Sherman got knocked out, there were 5 more behind it and 5 more behind those. When a Tiger got knocked out, there might not be any replacements at all because the factory was bombed or the replacement was stuck 300 kilometers away without fuel to drive it to the front. That's the difference between engineering for performance and engineering for war. Germany did the former. The Allies did the latter. Artillery deserves another look because it really was the king of the battlefield in ways that never get properly emphasized. When military historians talk about World War II, they focus on tanks and aircraft and infantry tactics, and artillery gets treated like a supporting arm, something that was there but not decisive. This is completely backwards. Artillery killed more soldiers, destroyed more equipment, and shaped more battles than any other weapon system. For tanks specifically, being caught in an artillery barrage was often a death sentence. You couldn't hide from it effectively because the shells were coming down from above. You couldn't fight back because the guns firing at you were beyond visual range, often beyond the range of your own weapons. You couldn't run because tracked vehicles aren't fast enough to escape a barrage, and moving just made you more visible to the observers calling in the fire. Soviet artillery doctrine was explicitly built around the idea of massing fires to achieve overwhelming local superiority. They didn't spread their guns out evenly along the front. They'd concentrate them, sometimes putting more artillery in a single sector than Germany had in an entire army group, and then they'd use that concentration to obliterate anything in their chosen kill zone. German tank commanders learned to dread the sound of incoming rounds because they knew what was coming next. First, there'd be ranging shots, observers adjusting the fall of fire. Then there'd be a pause, maybe a few minutes, while the artillery batteries loaded for full effect. And then hell would arrive in the form of hundreds of shells per minute, turning the ground into a moonscape, destroying anything that wasn't deep underground. Tanks in that environment had a life expectancy measured in minutes. Even if they survived the initial barrage, they'd be damaged, disoriented, possibly immobilized, and there'd be follow-up fires or a ground assault while they were still trying to get reorganized. American artillery added precision to the Soviet approach through better communications and better fire control. The Americans pioneered techniques where forward observers could call in fire missions and have shells landing on target within a couple of minutes, sometimes faster. They developed systems for massing fires from multiple batteries onto a single point, coordinating it all through radio networks that let them shift fires rapidly as the tactical situation changed. And then there was that proximity fuse technology, which turned every artillery piece into an anti-armor weapon, even if it wasn't firing armor-piercing rounds. The combination was lethal beyond anything the Germans could counter. They tried dispersing their armor to reduce casualties from barrages, but dispersed armor is harder to coordinate and easier to defeat in detail. They tried moving constantly to avoid being targeted, but that burned fuel they didn't have and wore out vehicles that were already maintenance nightmares. They tried digging in, but dug-in tanks aren't mobile, and mobility was their primary advantage. The mine warfare aspect needs deeper examination too, because it represents such a perfect example of asymmetric tactics working. The Soviets didn't invent the anti-tank mine, obviously. Mines had been around since earlier wars, and everyone used them to some degree. But the scale at which the Red Army employed them was unprecedented. They were laying minefields that were kilometers deep, overlapping fields where clearing one belt just exposed you to the next. They'd mix anti-tank mines with anti-personnel mines so that engineers trying to clear a path would become casualties. They'd plant mines in patterns that forced tanks into killing zones where other weapons could engage them. They'd even start using mines offensively, laying them during fluid operations to cut off German retreat routes or to channel counterattacks into prepared defensive positions. German mine-clearing capabilities couldn't keep up. They had specialized equipment, flail tanks and mine rollers and detection devices, but all of that was slow, resource-intensive work, and it had to be done under fire in many cases. A combat engineer team might spend hours clearing a path through a minefield, and then a single artillery barrage could recontaminate the area by throwing up dirt and debris that might contain more mines, or by creating craters that made the cleared path unusable anyway. The psychological toll on drivers and commanders was immense. Every time you advanced across unfamiliar ground, you had to assume it was mined. Every suspicious patch of dirt, every odd-looking rock, every place where the earth looked disturbed, those were all potential mines waiting to take off your track or blow a hole in your belly armor. The stress of that constant vigilance wore crews down faster than actual combat sometimes. Fighter bombers represent another technological evolution that Germany simply couldn't match in the later war years. Early in the conflict, the Luftwaffe had air superiority and could provide close air support to their own ground forces while denying it to the enemy. But by 1944, the situation had reversed completely. Allied aircraft owned the skies over both the eastern and western fronts, and German tanks had to operate knowing that friendly air cover was unlikely at best. The rocket-armed Typhoons and Thunderbolts and Soviet Sturmovix could appear without warning, and once they'd spotted a target, they'd circle back for repeated attack runs until they'd exhausted their ammunition. Even if they didn't score direct hits, the mere presence of enemy aircraft overhead was enough to paralyze German operations for hours at a time. The cab rank system worked because it solved the fundamental problem of close air support, which is getting aircraft to the right place at the right time with the right target information. Earlier in the war, close air support was often too slow. By the time you identified a target, called in the strike, got aircraft diverted to the area, and had them find the target, the tactical situation would have changed. The target might have moved, or friendly troops might have advanced into the area, or the moment where air support would have been decisive had passed. The cab rank approach eliminated most of that delay by having aircraft already airborne and in the general area. Forward air controllers, often flying in light observation aircraft or positioned with ground units, could directly communicate with the fighter bombers and talk them onto targets in real time. The result was that German armor could be attacked within minutes of being spotted, which made any daytime movement incredibly dangerous. Night operations became Germany's only real option in areas where Allied air superiority was total, but fighting at night has its own problems. Visibility is terrible, navigation is harder, coordination between units becomes much more difficult, and the pace of operations slows dramatically. What might take an hour in daylight could take 4 hours in darkness. This meant German armoured forces were effectively operating at a fraction of their potential tempo, and in mobile warfare, tempo is everything. If you can only move and fight for maybe 8 hours out of every 24, while your enemy can operate around the clock because they're not worried about air attack, you're going to lose the operational initiative no matter how good your equipment is or how skilled your troops are. The Allies didn't need to destroy every German tank with aircraft. They just needed to make German tank operations so slow and so costly that Allied ground forces could win through superior mobility and concentration. Returning to the logistics nightmare, it's worth examining just how fragile the German supply network actually was. Modern militaries understand that logistics is everything, that the famous phrase about amateurs studying tactics while professionals study logistics is absolutely true. But Germany in World War II seems to have never fully internalized this lesson, at least not at the level where it affected procurement and planning decisions. They kept building increasingly complex vehicles that required increasingly specialized support, even as their industrial capacity was being bombed into rubble and their transportation networks were falling apart. It's like watching someone dig themselves deeper into a hole while insisting that the solution is to dig faster. Consider what it took to keep a single Panzer division operational. You needed fuel, obviously, and not just a little bit. These were thirsty machines, and moving a division any significant distance required thousands of litres. You needed ammunition for the main guns, different types depending on what you were expecting to fight. Armour-piercing for enemy tanks, high explosive for bunkers and infantry, maybe smoke rounds for screening movements. You needed machine gun ammunition for the coaxial and hull-mounted guns. You needed spare tracks because tracks wore out and broke constantly, especially on the heavier vehicles. You needed spare wheels and return rollers. You needed engine parts, transmission parts, gun parts. You needed tools for the mechanics to work with. You needed trained mechanics who understood these specific vehicles because they weren't simple to work on. You needed recovery vehicles capable of towing a disabled tank, and those recovery vehicles needed to be as heavy-duty as the tanks themselves, or they couldn't do the job. All of that had to be manufactured, stockpiled, transported to supply depots, and then moved forward to wherever the division was operating. Every step in that chain was vulnerable to interdiction. Allied submarines hit cargo ships bringing raw materials to German ports. Allied bombers hit factories where components were manufactured. Allied fighters strafed trains carrying supplies to the front. Partisan groups ambushed truck convoys. Even when supplies made it all the way to a divisional supply dump, there was no guarantee they were the right supplies. A unit desperately needing engine parts might receive a shipment of track links instead because somewhere back in the logistics chain, someone had mixed up paperwork, or because the engine parts they actually needed didn't exist anymore because the factory that made them had been destroyed 3 weeks ago. German tank commanders had to become experts in creative improvisation just to keep their vehicles moving. They'd cannibalize broken tanks for parts to keep running tanks operational. They'd trade with other units, swapping ammunition types they didn't need for fuel they desperately required. They'd send scrounging parties to abandoned supply dumps and destroyed vehicles, looking for anything salvageable. There are accounts of German mechanics doing things that would horrify any engineer, like filing down parts that didn't quite fit to make them work anyway, or using components from one type of vehicle in a completely different type because they were similar enough that they might function for a while. This kind of field expedient maintenance can work in the short term, but it's a symptom of systemic failure, not a solution. You're not maintaining combat effectiveness, you're just delaying inevitable collapse. The situation got so bad that by late 1944, some German armoured units were effectively immobilised, not because they'd been destroyed, but because they simply couldn't operate anymore. They'd be pulled back to defensive positions and told to fight from static positions, using their tanks essentially as fixed fortifications, because there was no fuel to move them and no realistic prospect of getting fuel anytime soon. This is an admission of defeat even before the battles are fought. If your armoured forces, which are supposed to be your mobile reserve, your exploitation force, your ability to respond to enemy breakthroughs, if those forces are stuck in place waiting for supplies that never come, you've already lost strategically. You're just going through the motions until the end comes. The human cost of all this deserves mention too, because it's easy to talk about tanks as if they're just machines, just numbers on a spreadsheet. But every tank that got destroyed or abandoned represented a crew, usually 5 men for most German tanks, who were either dead, wounded, or at minimum traumatized by whatever happened to their vehicle. Tank crews suffered casualty rates that rivaled or exceeded infantry in many engagements. Getting hit by an armour-piercing round that penetrated could be instantly fatal for everyone inside. The physics of penetration are horrific. The round punches through the armour, and as it does, it creates a spray of molten metal fragments from the armour itself. Those fragments, plus the round itself if it doesn't disintegrate, careen around the interior of the tank at supersonic velocities. Crewmen would be killed by the round, by the fragments, or by secondary explosions if ammunition storage was hit. Even if a hit didn't penetrate, the impact could cause spalling, where fragments of armour break off from the inside surface and become projectiles themselves. Early tanks didn't have spall liners, so crew compartments would be filled with razor-sharp metal fragments every time the tank took a significant hit. Surviving tankers often had terrible scars from these kinds of wounds. Burns were common too, especially if the tank caught fire. Gasoline engines were dangerous in this regard, but even diesel tanks could burn if the fuel system was ruptured and ignited. Crews were supposed to bail out if their tank caught fire, and most did if they were able, but that meant abandoning all their equipment and exposing themselves to enemy small arms fire. Deciding when to stay with a damaged tank and when to abandon it was a calculation every commander had to make repeatedly, and there was no right answer. Stay too long and you might burn to death. Leave too soon and you might be giving up a vehicle that could have been saved. The psychological dimensions of tank warfare don't get explored enough in popular histories. Yes, tanks provided protection and firepower, but they also created a unique kind of claustrophobic terror. You're sealed inside a metal box, unable to see much of what's happening outside, completely dependent on your driver and commander to navigate and to spot threats. Every sound is amplified and distorted. You can hear things hitting the armor, but you can't always tell what they are or where they're coming from. Is that an armor-piercing round that failed to penetrate or just a machine gun bullet? Is the enemy ranging on your position or just firing randomly? Should you stay where you are or try to move? Every decision has potentially lethal consequences, and you have to make them with incomplete information while under enormous stress. Crews developed superstitions and rituals to cope with this. Some tanks had good luck charms, or crews would follow the same routine before every engagement, or they'd avoid certain behaviors they associated with bad outcomes. Rationally, everyone knew this was nonsense, that luck didn't exist, and that outcomes were determined by tactics and firepower and terrain. But humans need ways to feel like they have some control over their environment, even in situations where control is largely an illusion. Tank combat in World War II was absolutely one of those situations. You could be the best crew in the world, doing everything right, and still get killed by a lucky shot from an enemy you never saw. You could make a mistake and survive because the enemy also made a mistake at the same moment. There was skill involved, definitely, but there was also an irreducible element of chance, and crews who survived long enough to become veterans understood this at a bone-deep level. The final collapse of German armoured forces was as much a moral collapse as a material one. By the spring of 1945, everyone knew the war was lost. Crews were still fighting in many cases, following orders and doing their duty, but the conviction that they were fighting for anything meaningful had evaporated for most of them. Some fought because they were afraid of what would happen if they surrendered, especially on the Eastern Front where Soviet retribution was expected to be severe. Some fought because they simply didn't know what else to do, combat being the only life they'd known for years. Some fought because they still believed in the cause, though these were increasingly rare as the reality of Germany's situation became undeniable. But everyone was exhausted, physically and mentally, worn down by years of constant stress and loss. When units received orders to destroy their own vehicles and withdraw on foot, it must have felt like the ultimate betrayal, the final admission that all the sacrifice had been for nothing. These were vehicles they'd lived in, fought in, maintained through incredible hardship. Their tanks had kept them alive through countless engagements, and now they were being ordered to blow them up and walk away because the system that was supposed to support them had completely failed. Some crews couldn't bring themselves to do it and would try to hide their vehicles or hand them over to local civilians or just abandon them intact, hoping someone else would deal with the responsibility. But most followed orders, set the demolition charges, and walked away as their tanks exploded behind them. The symbolism is almost too perfect. German armoured warfare, which had begun the war with stunning victories achieved through speed and concentration and surprise, ended with crews trudging through the ruins of their own country, leaving behind burning wrecks that nobody would recover or repair. In the final analysis, what killed German tanks was the fundamental mismatch between their military ambitions and their industrial capacity. They tried to fight a global war against enemies who massively outproduced them in every category. They tried to compensate for quantitative inferiority with qualitative superiority, building better tanks that required more resources and more complex support structures. And when that support failed, as it inevitably would under the strain of total war, the whole edifice came crashing down. The logistics broke first, because logistics is always the most fragile part of any military machine. Then the supply of spare parts dried up, because bombing campaigns and resource shortages meant factories couldn't produce enough. Then the fuel stopped flowing because oil refineries were being destroyed and supply lines were being cut. And finally, the crews themselves, the human beings who were supposed to operate these magnificent machines, they broke too, ground down by years of impossible demands and diminishing returns. The myth of the tank duel, the idea that armoured warfare was primarily about one tank fighting another in some kind of mechanized joust, that myth served nobody's interests except maybe Hollywood's. Real armoured warfare was about systems, about logistics networks and supply chains, and industrial production, and air superiority, and artillery coordination, and mine warfare, and 1,000 other factors that are boring to explain but absolutely crucial to understand. German tanks didn't die in glorious combat, at least most of them didn't. They died in mud and fire and mechanical failure. They died when their crews ran out of fuel or ammunition or hope. They died when the spare parts they needed didn't exist anymore, when the factories that made those parts had been bombed into rubble. They died when mines ripped off their tracks, when artillery shells rained down from unseen guns, when fighter bombers appeared overhead and crews had nowhere to hide. Understanding this matters because it tells us something important about modern warfare, about how conflicts are won and lost. Superior technology helps, sure, but it's not enough by itself, and it never has been. What matters is sustainability, the ability to keep fighting, to absorb losses and replace them, to maintain supply lines under pressure, to adapt and improvise when things go wrong. Germany built beautiful tanks that performed magnificently in ideal conditions. But war rarely provides ideal conditions, and when those conditions disappeared, so did Germany's armoured advantage. The Allies built adequate tanks that could be maintained and supplied and replaced, and they backed those tanks with everything else needed to win an industrial war. Artillery, air power, logistics, industrial capacity, all of it working together as a system designed to grind down the enemy through relentless pressure applied across every dimension simultaneously. That's what killed the Panzers. Not heroic tank destroyers, not skilled enemy tankers, though those existed and played their part. What killed them was the arithmetic of attrition, the logistics of total war, and the simple fact that Germany bit off more than it could chew and then choked on it. By the time the fighting ended, German tank forces had been reduced to scattered remnants, individual vehicles here and there still functioning through pure stubbornness and mechanical skill. But the organisation, the supply network, the industrial base that had created and sustained them, all of that was gone. The war ended not with the last German tank being destroyed in combat, but with the last German tank sitting broken by the roadside, abandoned because nobody had the fuel to move it, or the parts to fix it, or the will to keep fighting a war that had already been lost. That's the real story of German armour in World War II. And it's far more instructive than any movie could ever be.